I can't see what's on there. I can see what's on here. So, testing, as I said earlier, we all rely on some level of testing or other. And this is the bit that says that testing is commonplace, absolutely commonplace. You put your toe in the water as an expression that's got all sorts of things associated with it. Test of sharpness. You know you don't go like that down a knife blade, you go like that across it to test its sharpness. Verification of text. There's all sorts of tests that these literary people can do. Patents are a test of veracity. Is it true? Will it work? And of course we've got the gold and silver assayists, which have been around for centuries. They're testing the quality of the metals. And also we're saying fit for purpose. One interesting thing, a pair of phrases, I think it's a pair, that come up in a lot of the current Scottish fire safety guidance is, I've forgotten the first bit, the second part, is the building safe and is the building fit for purpose? It's a very big phrase, fit for purpose. And will it go faster? Ask Hamilton. Do you have enough knowledge for the task? A self-test. All these things are tested. More to our liking is, should we dim the lights? If we can, a bit. Will it ignite? Back to the fire so-called triangle, which is really a square. Will it release heat? Or will it absorb heat? It's an area that we don't normally tread. Will it absorb heat? Cognitive testing. Do you really understand what you are doing in the context in which you are doing it? Do you really understand? And I put this last one on. Just thought, what a good idea. Test for limited performance. A lot of you will have heard about when one tests structures, that you're saying, okay, you can test it, but what is its limit of reuse? There are limits to that, and of course test to destruction, which is a delight if you're not underneath it at the time, because you know its absolute limit. It's gone through all sorts of other stages of destruction as a structure, but when you get that far, you say, okay, what happened? I did a lot of testing on reinforced brickwork, but we're not going to tell you about that because it's a long story and we haven't got a long time. So within technical testing, especially the sort that we are aware of, is we test the materials, or do we? We test the materials. We test the components and the systems, or do we? Do we test combinations of systems? It's like the old story when a fire officer, this is before 1971, went to a building and thought a switch was a bit loose. It happened to be a break glass core point, a bit loose on the wall. So they took it off the wall with no wires. No wires. Do we test the combination of systems? And the combination of system leads us to design. So we've gone a lot of the way through testing when we come to design. We are relying on the outcomes of these other previous tests. And design needs to be tested as well. Now this story about, okay, we test it against the regulations. What cobblers. We test it against the needs of the people who are going to be using the building, and is that building fit for the purpose for which it was designed? We're not trying to comply. I wish people would get over that, because compliance is the most rock bottom minimum standard, which doesn't mean a great deal. Then I've got the obvious ones: production, installation, and interactions. Well, production and installation, that's fair enough. But was it easy to install or was it not? Was it difficult to manufacture or was it not? When you want emergency lighting inside a handrail and still perform, that's quite a difficult production task. But in the event, it can be the best thing you've ever tried to do. Be adventurous. And just to go a tiny bit more into detail, natural wind and smoke control. There's a lot of misunderstanding about this. And the pressure patterns that are developed around obstacles are very important. How clear is this? And there's a lot of wiggly lines, but not bad. It's bad enough. Can you see it at the back? There's wiggly lines. Not much more. Okay, well that's a model of a wind flow coming along that 4-height block in the middle. As you can see, it doesn't disturb very much because there's not much to disturb the wind flow. But then we complicate that. Some of you have seen this a lot of times before. We change the wind around a little bit, 45 degrees, and we blow onto the model again. And oh, hey presto, we've got positive areas on the horizontal surface, and on the other side of the block, negative areas. Think for a moment, positive and negative areas, potentially above the same space. Because that large rectangle could be one space. And if we move the wind around yet again, we find that we have increased pressure contours, increased values. And again, on the one side there are positive, and on the other side there are negative. Now, I've used this concept to decide or to persuade a client or whatever on whether he or she needs powered extract from the space underneath or whether natural will be all right. Because the last thing anybody wants is saying, oh, open the vent and the wind comes in. Now, this is part of the result of about, I don't know, 10,000 measurements. So one has to be a little bit circumspect about some of it. But that work was done for the fire research station when it was still in existence, and it was used in their consultancy work for a long time because they were involved in advising people about smoke control systems for decades. Now, this is jumping a little bit to the choice of suppression systems. And we all know that there's gas, there's liquid, and there's solids that we can use as suppressants. But we need some sort of test to determine the efficacy of contents, especially in retrofit. There's a huge cry at the moment about retrofit. Oh, sprinklers, everything, everybody will be safe. Everybody could be dead. People don't think, somebody mentioned, I think, that, yes, you did, holistic view of some of these things. Well, holistic isn't being practiced if you say, just put sprinklers in and everything will be all right. Is that fair?
Probably better. So,
it won't be worse, but it won't be as good as it could be. Okay, we accept that. But everybody will accept that. And this is one of my favourite buildings, which is now demolished, because this was redundant at the time, otherwise I couldn't have set fire to it. It was the vehicle maintenance building for a lemonade factory in Edinburgh. There's housing estate now. And that's the inside. I think you can see something of it. That's empty space, but that was where they did the vehicles, and that's what we set up. Basically, a test cell. And, oops, I've got the wrong picture here. And as you can see, you don't get much more full scale than that. And you'll see why I'm showing you these, because testing is very fraught That's simply an indication of the sort of stuff we were burning or trying to set fire to. And you'll see in the foreground a rather lonely chicken wire cylinder with shredded paper stuffed inside. That was one of our standardized igniters. It worked. You can see some more between the other documents. And on the upper photograph, you can see one where the fire got away, because we're only testing water mist. And water mist doesn't always work. When it doesn't work, you've got a bigger fire than you thought you were going to have in the first place. The standard is fine, 300 grams of water for every cubic meter. Not a lot. But it doesn't always go. And you'll see there in the lower picture some of the rather charred remains here and there. Now, what was decided was gas. And that amount of cylinders is needed for about 50 cubic meters of space. It's a lot of cast iron. And so one has to be terribly careful about how much space will your solution require. It's like some of the smoke control systems I've done for various buildings, and I say, well, you've got to dedicate a room for the controls and the fans. A room, gone. And that's when you pay, when you've been getting your earnings from that, it's quite something else. You don't want to lose the revenue. So space. Now this is just another thing that happened in passing that I remembered. The architect decided that he didn't want anything sticking from the ceiling plane. Well, I can understand it to some degree. And the building is still for sale, if you want it. It's quite elderly now. And the return air in this air handling system was led to numerous small plenums for extract. And we put detectors inside the return air plenums. Now, somebody will say, there's supposed to be a detector in return air systems anyway. Fine. But this was in return air plenum nearest the ceiling. And there was a difference of 16 seconds between on the ceiling and in this little plenum. And building control and I decided that 16-second delay when you were in an open plan office was not a big delay. When you read of 4-minute delays in shopping centres and department stores, I think that's almost criminal. But that's another story. Now, you might not like this one, but we were allowed to burn bits of Barlini. Anybody here not know what Barlini is? Somebody will tell you. It's a Victorian jail in Glasgow. Lots of spaces for lots of people. And we were given the whole of the contents of a cell to burn, of course. And the worst material was the soles of the issue boots. This is gram for gram. The worst material. And the boots were replaced. The worst item, in other words, which product was the worst, was naturally, at that time, foamed polyurethane mattress. And they had a program, Scottish Prison Service, had a program of mattress replacement, which this sort of encouraged. And we used the NBS smoke release equipment that some of you will be aware of in an 8 cubic meter room, which is one of their standards. Some of you will have burnt stuff in such a room. Yes? Oh dear. So, I'm going to get moved on to that. So tests of all sorts are very important. The difficulty is one has to consider the context of the test and consider the application you're going to give to the results. It's no good saying, I've got a box of matches which I have invented. The different match will take a very long time to burn. therefore it is fire safe. There weren't so many matches. But I was asked one year to give a lecture to a group of ASH people, anti-smoking, whatever they are, people. And I thought, I don't know anything about this, so I borrowed a book from Dougal Drysdale. He had a book about it. And I read this book, big book, and I gave this talk on the fire-safe cigarette. Is it? Or are you killing everybody a different way? I don't know. But they didn't, I never had any, so who knows. Some tests, like the furniture ignition test, is a product test, it's not a real test. You know what the furniture ignition test is? Don't think they make them anymore. Senior service, untipped cigarettes, lit, placed in the crack between the seat and the back of an upholstered chair. If the seat catches fire, it's failed. If it doesn't, it's passed. That is a product test, it's not a test for approvals. Your chair's still going to burn like the clappers if enough heat gets to it. Yeah? And so, and I've just had to put that at the bottom. Again, some of you will have been near one of these things at £200,000 each, thereabouts. Is it more? The cone calorimeter. If anything, as a physical test, is prone to fudging, it is the cone calorimeter. Who knows about the cone calorimeter? You're not admitting it, I can feel that. It's like, if it burns, oh dear, let's do it again, and move the sample a bit further away from the heating elements. Oh, that's all right, it takes 10 seconds longer. Pass. I don't have much faith in some of these tests, as you might have imagined. And I've done them all, or been where they are. Thank you. So, that's my story, and I'm sticking to it. And as I said, I have a printout here of all of them. If anybody wishes to do that, take them. So, I'm not going to prolong any questions, but are there any questions you would like to ask each of us? All of us have got an answer. Who puts really great faith in test results? Come on, somebody must.
It depends on the context. Yeah.
Well, exactly. But the whole point is that you can't have a test that's done for, well, no, I shall just say one thing. Grenfell proves that, first of all, you can misunderstand the conditions of test, which was done hundreds of times in the last few weeks. You can misunderstand the words of acceptability descriptions, which was done many times over the last few weeks. And you don't, the condition of the building, when it was new, wasn't taken into account in interpreting the test results. Not a very good picture. So,
in terms of the testing you spoke about on your testing slide 2, you went through essentially what are the design tests. But if you take it to the second phase of what we have, going holistic, as I said earlier on, you get to the operational phase of things, and then you then get into an ITM, inspection, test and maintenance testing regime. And that's I think the important thing that we need to do as well, in terms, it's not just something passing a test in isolation, or even passing a test, a cause and effect proving exercise, if you like. You've got to continue to do that throughout the life of the building. So it's
I agree. Now, the whole point of what you said is that everybody that I've met seems to want fire risk assessment on the cheap. I've done one fire risk assessment that cost somebody £300, and I've done one that cost them £3,600. Now, both were completely acceptable to the management of the two places, but obviously one took a lot less time than the other. Now, they are thinking clients, and I think this is where post-completion testing is crucial. One building that I was asked to go to, and it was a very, very simple test that I had to do. I was asked by a building contractor to come across from Edinburgh to the west of Glasgow to go to a new building completion site, completed buildings, and they said, none of these doors are closing. These were room to corridor. Why not? Simple question. The doors and their closers had failed to close. Fair? So I thought about this a tiny bit and said, you need to make a hole in the window. That was it. It's because the ceiling, the seals around the windows and the doors were so good that there was, as the door closed, the negative pressure stopped it shutting. Now, very simple. But you see, that's post-occupancy almost, post-occupancy. But this is where the fire risk assessor now comes into the picture. What does work, what does not work? Do we get enough time to find out? I ask anybody who does fire risk assessment, do we have enough time to find out? Do we do it properly? There was some Scottish government thingy that said, should the fire risk assessor look above the ceiling?
Yes.
Well, you and I agree, every time. And I used to say, what you're doing as a fire risk assessment is a first cut. You must identify all the potential problems so that when somebody else comes to look at those potential problems, they can find a solution. And I was shown one building in Glasgow, and the chap said, the facilities manager, he said to me, he said, look into that staircase, which I did. He said, you see down there, there's a grill. I said, yes, I can see that. I said, that is for the quarter air change an hour because it's a sealed staircase. You need the quarter air change an hour to keep replenishing the whole thing. He said, yes. The inspecting officer thinks it's a pressurization system. I said, well, has he ever asked to see the fans? Oh no. How carefully do we do fire risk assessment? How carefully do we do fire risk auditing? You see where I'm getting to. They were sort of obvious tests that I've shown you. Obvious in terms of if it's not going to pass, it'll fail dramatically. And Jim McGonigal is going to say something about cables.
Yep.
Cables, essential bits.